Hi everyone, this is Mr. Bainey, and today's lesson is 3.3 Modeling with Functions. Thank you so much for watching this video today. The essential question is, what is function notation and how can you use functions to model real-world situations? So we have some new vocab here. If you remember back to I think the few previous lessons, we have domain and range. And let me use a different color here actually, because I want to give you a little review that domain is our inputs or our x values, and range is our outputs or our y values. Independent variable is going to be like our x value, and dependent is going to be our y. That's what it's going to refer to. Let's look at the explore to look a little bit more deeply into what independent and dependent actually mean. This is going to be very important in helping us write some of these functions down, or equations as we called them previously. So if I look at the situation, in the winter, more electricity is used when the outside temperature goes down and less is used when the temperature rises. So we have two quantities here. Quantity means something that's going to represent a number, and I want to put something here and here. So what depends on what in this problem that's right here? So the more electricity used when the outside temperature goes down, and then vice versa, less is used when the temperature rises. So the amount, or I want to say the use of electricity, because we can actually measure this, so this is a quantity. It depends on the outside temperature, right? So it wouldn't make sense if you said the temperature depends on the amount of electricity. That would be really weird, because it's like saying, if I use more electricity in my house, that's gonna all of a sudden determine what the temperature is. No, it's the other way around. The temperature is gonna kind of determine how much electricity we use, like for AC or for the heater. So the dependent variable is what we wrote first, the one that depends on the other. So dependent is the use of electricity, and the independent is the outside temperature. I'm going to do just one more of these, and part C says the cost of shipping a package is based on its weight. And so think about this. We have cost, right? That's a quantity. And we have weight. That's our other quantity. So does cost depend on the weight, or does the weight of the package depend on the cost? So it's going to be the first one, the cost. So think about which one just makes the most sense. The cost is going to depend on what the weight is. Okay? You don't know the cost and then all of a sudden the weight is going to change because of the cost. So the weight is, we already know what the weight is, right, of a package. So the dependent variable is the cost of shipping, and then the independent variable is the weight. Okay, let's take a look at the next page. And we now have a different notation. So this is going to be an important lesson for us, because we're going to be using this new notation quite a bit for the rest of the school year, and also in higher math levels. We have this thing called function notation. And function notation is now going to change our y to f of x. So y is now going to become this weird thing right here that looks like f times x, but we read it as f of x. Okay? F means function, although we can use different letters there. It really means function of x. And so let's take a look at how this actually works in our equations. So we're going to write an equation in function notation. So we have this situation. Amanda babysits and charges $5 per hour. So there's a table of values. We have a description as well that we can use. So to write our description here, part A, the cost is $5 times the hours worked. Okay, and what's good to think about here is, does the cost depend on the hours worked, or does the hours worked depend on the cost? And so right now it's in the correct order, so the cost is going to depend on the hours worked. So cost is our dependent variable, or our y. Remember that. It's our y value, or now it's this f of x value, right, that we're using. That's new. So part B, we're going to write down an equation. So the amount earned, we're just going to use y for now, just so it makes sense without using that function notation. So y is going to equal 5 times x. Let me write it down here. Y equals 5x. Okay, so that's going to be our equation that we're writing. But it's really, in function notation, f of x equals 5 times x. So f of x equals 5x. So compare those. Look how similar they are or how different they are. We want to start using this function notation, the second one that I wrote down. So let's take a look at another example. Okay, part B on page 129. For each example, identify the independent and dependent variables, and we're going to write an equation in function notation and then use it to solve the problem. So part B, the admission fee at a carnival is $9. Each ride is $1.75. How much does it cost to go to the carnival and then go on 12 rides? So we need a dependent and an independent variable. We need to figure out the two quantities. Right? That's the hard part. The quantities are the things that represent numbers. Don't give me numbers, but I want to know what is a description of the numbers. So we have, looks like cost, and then we have rides, the number of rides. So does the number of rides depend on the cost, or does the cost depend on the number of rides? Okay, so the cost depends on the number of rides. So the rides is going to determine our cost. Because you can go on 12 rides, it'll be a cost. You can go on 5 rides, it'll be a different cost. You can go on 20 rides, and that'll be a different cost. Okay, so the cost depends on that. And it says plus $9. So the dependent is cost, the independent is number of rides. So we're going to let our independent variable r represent the number of rides. Okay. They're using r, but you could use x, right? X is the more common one. So f of r, remember that this right here, f of r is our output. That's replaced our y. This represents our dependent variable cost. So our cost equals the 1.75r and then plus $9. So now we're going to substitute in 12 for r to figure out this problem, right? We need to answer that question. So instead of f of r, right here, we're going to write f of 12. Okay? And that's going to equal 1.75 times 12 plus 9. And we just multiply that out, so 1.79 times 12. And then add 9 will tell us the cost for 12 rides. And that is 21 plus 9, which is 30. So what's nice about this function notation, so take a look at that last line. This tells us the input and the output at the same time on the same line. This is why I really like function notation, and it's more efficient for us. So it's going to cost $30 to go on the carnival, to go to the carnival and go on 12 rides. Okay, both of those, the input and the output, are in that last line. Try the your turn, try it out, and then check out my solution. So our independent variable and dependent variable, we want to identify those for number 4. The dependent is the cost, because the cost is going to depend on the hours, and it's not really cost. They don't say cost. It's the money earned is going to depend on the hours worked. So remember that the dependent variable is going to be our f of x. So this is our dependent. Remember, this represents money earned. The money earned is going to be $7.50 times the number of hours worked. That's our independent variable. And then from here, we want to figure out how much does she earn working for 8 hours. So I do 7.50 times 8, and that is 60. And so I won't write down the sentence, but be able to interpret what this last line means. This means that she earns $60 after working 8 hours. Okay, page 130, the last type of example that we have for this lesson. You'll want to know how to write a function in function notation and then find a reasonable domain and range for each function. So we're still practicing writing these out. Number 5, the temperature early in the morning is 17 degrees Celsius. The temperature increases by 2 degrees Celsius for every hour for the next 5 hours. Write a function for the temperature in degrees Celsius. So it doesn't tell us to do it here, but it's a good idea to identify the independent and dependent variable, right? We can't write a function if you don't even know what the independent and dependent variables are. So it looks like the dependent variable is the temperature, because the temperature depends on the hours, a number of hours, I guess. Okay, so it increases 2 degrees Celsius for every hour for the next 5 hours. So here's my function, f of x. Remember that f of x represents temperature. And how does the temperature change? Well, it increases, so that's a positive 2 times x, and then plus 17. It starts with 17, and we're adding 2 for every hour. And we don't need to work these out quite yet, but we want to identify our domain. It says it increases that much for the next 5 hours. So our domain means how many hours make sense in this problem. Well, I could do 0 hours, 1 hour, 2, 3, 4, or 5 hours. Okay, it may not increase 2 degrees Celsius after the 6th hour or the 7th or even the 10th or 15th hour. That wouldn't make sense. So that's not in your domain. Now the range, I'm going to do some mental math here, so see if you can follow along. The range is going to be determined by our domain. So if our domain value is 0, think about what the temperature would be. The temperature, that would be 0, and then temperature would be 17 degrees Celsius. If the domain is 1, substitute 1 in here, and that would be 2 plus 17, which is 19. So my range would be 17, 19, 21, 23, 25, and 27. Okay, so that would be my reasonable domain and range. Remember that the range depends on the domain values that you've picked or identified. Okay, try number 6, last one here. Takumi earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours a day. Write a function for his earnings. So the dependent variable is the earnings, and the independent is the number of hours. Right? The earnings depends on the number of hours worked. Our function is f of x, that's our earnings, equals $8.50 times x. Works no more than 5 hours a day. So our domain, no more than 5 hours. That means he doesn't work more than 5 hours, so he can work 0, 1, 2, 3, 4, or 5. And it sounds like he can work also things like 4.5 hours, or 4 hours 10 minutes, or 4 hours 45 minutes, or 2.5 hours, and so on. So our domain is actually going to look a little different here. If you listed it as 0, 1, 2, 3, 4, 5, then you are not including everything that could be the domain, right? That could be the number of hours that he worked. So I'm going to put that x is in between 0 and 5, like so. Okay, it does make things a little bit confusing, but it's just another way to write our domain. Remember, we can use our compound inequalities to do that. So our range is going to depend on this domain. So if he works 0 hours, right, that's the start of my domain, he earns $0. So now this earnings, f of x, is in between $0 and then 5. I want to figure out, if he works 5 hours, how much money did he earn? And he earns, looks like $42.50. So he can earn anywhere from $0 to $42.50. Anywhere in between that could be his earnings based on the number of hours that he works. Okay. All right, that's it for this lesson. Thank you so much for watching, everybody. Have a good day.